Welcome back to the end of chapter 12 and the end of 11:10. Yay! Benzene and properties. We're going to talk about benzene rings and all the different properties it has. And benzene is a good place to start here. Benzene ring, remember from the last one, is a hexane ring with every other bond being a double bond. And since we can't justify or figure out exactly where those bonds are because they spin in space, we put a circle in the center, and basically that circle tells us every other bond is a double bond. Now, knowing that every carbon on that ring can only have one thing coming off of it, remember that they can only be bound to a total of 4 things. So we have some specific benzene rings with things coming out that we name a certain way. Now, ethylbenzene, that would be pretty easy, this first one. Nitrobenzene is probably one that you're not more familiar with. So anytime I have an NO2 group, that's a nitro group. And we just put benzene because it's attached to benzene ring. Bromo, we've done that before. If there's one attached, it becomes bromobenzene. And chloro, sorry, I forgot the L, so we'll put it in there. Chlorobenzene for one that's attached to a chlorine. So those are pretty straightforward. The only one new one is the nitrobenzene, so keep an eye out for it. Some others that we use a lot that don't necessarily have a way to remember them like we have before are these 4. Toluene is a benzene ring with a methyl group attached. We don't call it methylbenzene, we call it toluene. Because toluene is found in so many things, it's a lot easier than saying methylbenzene, methylbenzene, methylbenzene over and over again. Just like we give benzene its own name instead of saying 1, 3, 5, tri, cyclohex, or whatever, triene. We have an alcohol attached, we call it a phenol. If we have an NO2, instead of calling it nitrobenzene, we call it an aniline. And then if we have an acid ending coming off of it, we call it benzoic acid. We worked with this one in lab. So now you know what benzoic acid looks like. These are ones that you should become very familiar with. Okay? We're not going really deep into naming aromatic structures, but you do need to know the basic ones, and these are the basic ones. So let's go to actual naming. So what happens when a benzene ring is coming off a long chain? Instead of trying to name the chain off of the benzene ring, we name the benzene ring off of the long chain. And we call it a phenyl group. So just like isopropyl or T-butyl or whatever, we call it phenyl. So as we go to count this chain, starting from the left going to right, 1, 2, 3, 4, 5, 6, 7 is the longest chain, which is a heptane. We would say 3-phenyl heptane. And we would be done. So same kind of naming that we've done in the past. Again, bonds would win if I had any double bonds in that long chain for naming which direction it would go. What happens if I have more than one? We actually built one of these in lab. And when we did our model lab, we still go with the longest chain, and that's the center one. We're not going to worry about the cyclics because we can call them phenols. And it doesn't matter which way I go because I have 5. So 1, 2, 3, 4, 5. Now again, we have 2 phenyl groups. They're both coming off the same carbon, which is number 3, but we still have to say, oh, one's at 3, one's at 3, and I have 2, which is di. Then I would put phenyl. Then I would name the long chain, which is pentane, since it has no double bonds. And I would be done. Fairly easy. Just treat it like something coming off. Now, we also have specific ways. Instead of saying like ortho, instead of saying 1, 2, and going on, we just put O and then go on. Instead of saying 1, 3, we just say M and go on. Instead of saying 1, 4 and going on, we say P and go on. Now, if they're not the same thing, if I wouldn't have said 1, 2 dichloro, 1, 2 dimethyl, if I had 2 different things off, I still would say at the beginning O, then list them in alphabetical order. For instance, if I have this with a chlorine up here and a bromine right here, I would list it as saying O. Bromine comes first, bromo, then chloro, and then benzene. Okay, so it saves a little bit of time. So, or I think orthodontist, right next to each other, they want those teeth tight. Meta, I just met you, so I like to have a little of my space. And we're not real close friends, so I like to have you one space away. So meta. And then para, opposite. Okay, so para is opposite. Just quick ways to remember how to do that. But naming, very simple. Okay. So let's look at some different groups. We're going to number them so that the benzene ring count, we count in a direction that will give us the lowest numbers. And to know where to start, it's always if there is something coming off, like a specialty group that we named earlier and had a specific name, we start there and then go around the benzene the lowest way to get the lowest numbers. If we don't have one, like on this first one on the left, we count according to alphabetized things coming off. So bromine is 1 because it's a B. Then I would go to 3. So this is also what position? This is meta. So I could just go M, bromine. Now notice I put the dash between there. It's just like a number when I do the M, P, and O. So bromo, chloro, benzene. Now on this one, this right here actually makes it a phenol. Okay, so we're going to have a phenol at the end. And I've got things coming off. I've got a methane group here, and I've got a chlorine group here. So I want the lowest numbers. If I go clockwise, I'm going to get 3 and a 6. If I go counterclockwise, I'm going to get a 2 and a 5. Those are lower numbers, so I'm going to go that way. So I'm going to go 1, 2, 3, 4, 5, 6. Now I put them in alphabetically. So I would say 5 chloro, do I have enough room here, and 2 methyl, and then phenol. All right, on this last one over here, I also have a special group here that makes this benzoic acid. So I'm going to end it benzoic acid. And I'm writing it like this because I don't think I have enough room. All right, so again, I want the smallest numbers going around. So to do that, I'm going to start here with 1, then go counterclockwise around because I'll get the lowest numbers. I've got 2 groups coming off. I've got a bromine and I've got a methane group. So I'm going to number the bromine because alphabetically it comes first. So I go 2-bromo, and I'm going to have to stack these, sorry. Then I put the 5-methyl benzoic acid. All right, I hope that was helpful in being able to name things that are attached to benzene rings. We get also in benzene rings where a lot of benzene rings attach to each other. These are known as polycyclic aromatic compounds. They share a common side. So if you notice on the simplest one here, naphthalene, they share that center thing, that center bond right there. Naphthalene is actually used, or has been used in mothballs. A number of these polycyclic aromatic compounds are known carcinogens, which are chemicals that cause cancer. So we have to be careful around them. But some of them are very important. We'll get to those in a minute. A lot of carcinogens, or a lot of these polycyclics, are formed when we heat organic materials to high temperatures. So like for instance in a forest fire, or smoking gives off a lot of them. Volcanoes, even barbecuing. Now, they are also good, so we have to be careful. We have benzene and toluene that are used in industrial and laboratory as solvents. They make really good solvents and degreasers, but we have to be careful how we use them and what we do around them. They're also very good starting points for the synthesis of hundreds of other valuable aromatic compounds that make our plastics, that make a lot of the things we use in our daily lives. So they are good. They have good things. We just have to be careful with them. There is a number of them that we have to intake into our bodies because our bodies cannot make them. Phenylalanine is an essential amino acid, and our body can't make it. We have to take it in. So is riboflavin. That is benzene, has a benzene ring in it. It's vitamin B2, and we have to take it into our body. It has to be eaten and brought into our body so our body can use it. We cannot make it. So we have to also know that, with every bad thing, there are good things too. There is a table in the back of your chapter 12 that goes over several other important aromatic compounds. And it would suggest that you go and look at that and see what they are, what's important, like toluene and benzene and phenol and allyl and styrene. These are all important compounds that are used in our world today. I put on here a site that is a good site to go to for practice. I've also put a link on it on my blog so that you can go to it. It's nice because it asks you questions and you can take time to draw it, and then you scroll down a little bit and it gives you the answers. So with drawing organics, it's nice to be able to see if you're doing it right or not, and then I think this is a good site to do that. All right, so the next one is the review, and then we're done for the year. So stick with it. We're almost there. See you in class.